Yes, hello, is this audible? Yes, class, are you able to hear? All right. You're not able to unmute yourself. Just now try.
Yes, teacher, now we can unmute.
Now you can. Okay, fine, fine. Okay, so we had started with potential energy in the last class. So potential energy was the work done required to make our system or assemble our system to bring all the charges from infinity to their respective positions. So we had seen the general formula for 2-point charges of potential energy as K Q1 Q2 divided by R. Means K the constant, Q1 Q2 both the charges, R is the separation between them. Now if we relate dipole with the potential energy, then work done's formula, which was equal to the change in potential energy, this came out to be minus PE cos theta 2 minus cos theta 1. Then we had seen these three cases if only potential energy is there. And then I gave you a question. Did anyone try?
Yes,
Okay,
teacher.
if you have tried it, just send your answers in the chat box. Okay, let's discuss it. So electric dipole, P is 2 coulomb meter. Electric field is given to you as 10 Newton per coulomb. You have to calculate the work done by external torque in rotating dipole from parallel to anti-parallel position. Now, parallel means your cos theta means your angle theta is 0. Anti-parallel means both are in 180 degrees. So your theta 1 becomes 0, your theta 2 becomes 180 degrees. So in the first part you have work done by the external force. This is equal to minus P, that is 2. E becomes 10 cos theta 2, that is cos 180 degrees minus cos 0. So this is minus 20 minus 1 minus 1. So this becomes minus 2 into 20 minus 20 is 40 joules. 40 joules is the work done. Then in the second part is it says that what is the work done by electric field. So whatever work done is done by the external force, the negative of it is the work done by external field. So work done by electric field, this is the negative of the work done by the external force. So this becomes minus 40. Now third part says calculate potential energy. So whatever work is done, that gets stored in the form of potential energy. So it means, do we need to calculate that? We already have the work done. This whole work done by the external force, this gets stored in the form of potential energy, the change in potential energy. So this will also be 40 joules. Calculate potential energy if dipole is placed at 60 degree with respect to field. So in this was the third one. In this, we can use minus PE cos theta. So minus 2 into 10 cos multiplied by cos 60 degrees. So this is minus 2 into 10 into minus half, sorry, not minus half. So this becomes minus 10 joules. All right, so quickly note down the solution, then we'll begin with capacitance. Meanwhile, when you're writing down, all of you just send me in the chat box whatever topic or whatever chapter and the topic is currently going in your schools. In physics, whatever is the chapter going right now or whatever is the topic going. Please quickly, while writing, all of you send me that also. Okay, Akifa. Rest of you also please let me know. Fine, Heba. Atif, what about the chapters that come in between? This is chapter 4 and you are talking about chapter 1.
Teacher, we actually have like two teachers like teaching us separate chapters. That's why it's like this.
Okay, okay. So written?
Yes, teacher, I'm done.
Fine. Now let's start with capacitance. So this completes your potential portion of this chapter, half of it, and now we'll be discussing capacitance. So firstly, understand what is meant by capacitance. This is a very easy topic. Capacitance basically means the ability to store charges. These ability to store charges or potential energy. So basically, capacitance is the ability to store charges. This is the basic, simplest definition of it. And the device that is used to store charges, that is known as a capacitor. So ability to store charges is known as capacitance. Now, apart from this, there is one more definition of it. Capacitance is also known as the ratio of the charge stored by the potential that the body is holding. So it is the ratio of the charge and the potential or the voltage. So the formula of capacitance, this becomes Q divided by V. Q is the charge, V is the potential, and this capacitance is represented through the symbol capital C. So if the SI unit of it, which is means 1 coulomb per 1 voltage, this is said to be 1 Faraday. So you use the symbol F to represent 1 Farad. Now the device that is used to store the charges, that is known as a capacitor. So a capacitor, this is basically the device used to store charges. Now you can construct this capacitor by any ways. Capacitor can be constructed if you have two conductors with you and both of them are oppositely charged and the medium between them is insulating medium. Now see, if you remember when we were discussing Coulomb's law and when we were discussing electric field, then we did dielectric. So dielectric basically means the insulator or insulating property of a medium. If I put a dielectric medium, then charges won't be able to travel. There can be electric field, but what will happen? The electrons won't be passing. All the properties of insulator, whatever you have studied in your lower classes, that is valid for dielectric. So in capacitor, what you can do, for example, any shape, let's say this is one plate, this is another conductor. These are two conductors. I make this conductor as positively charged and I make this conductor as negatively charged by some means, by connecting to the terminal of the battery. Now, whatever medium is here, this has to be a dielectric medium. So I can call this arrangement, this setup as what? As a capacitor. This is the definition of a capacitor. Let me write down that also. Capacitor is what? Capacitor consists of oppositely charged conductors. Two oppositely charged conductors which are separated by a dielectric medium. So separated by a dielectric medium. Now, capacitor can also be of various types. See, capacitor, you can take the example of the flashlight in your mobile phones. What happens when the flashlight is on? All the charges come out, then you charge your mobile phone, then your phone gets charged back. So those charges that were stored, which came out as flash, those were stored in what? The capacitor of your mobile phones. So an example of it will be flashlight of your mobile phones. Let me write down that also. Example of capacitor. This will be flash light of mobile phones. So capacitor mainly for industrial uses are of three types. See, as I've told you, if you have any two conductors which are oppositely charged and I have a dielectric medium between them, then you can say that device is your capacitor. But in general, we have three types of capacitors. One is parallel plate capacitor. In case of parallel plate capacitor, what will happen? Both the conductors will be having shape of a plate, will be there in the shape of rectangular plate. So that we call as a parallel plate capacitor. Then that both the plates are connected to the opposite terminals of the battery. So whichever plate is connected to the positive terminal, that plate becomes positively charged, and the other plate that is connected to the negative terminals becomes negatively charged. Then we have spherical conductors as well. Spherical plate capacitors, not conductors, sorry, capacitors as well. Both the spheres are there, which are charged. They act as capacitor. And we have cylindrical plate capacitors as well. In case of cylindrical plate capacitors, you have capacitors in the form of a cylinder. So these are capacitors. These are generalized, standardized industrial use capacitors. But you have to remember that capacitor can be any device which can store charge. And for construction, you require only two conductors which have opposite charges. Fine. So just quickly copy these points, then we'll see one more important formula for capacitor apart from this. So remember this formula. Capacitor is what? Capacitance is charge per unit voltage. All right. Now the capacitance of a conducting sphere. before that, just tell me one thing. If this is a sphere, the charge on this sphere is, let's say, capital Q. The radius of the sphere is capital R. So we have done this. What is the potential on the surface of this? Charge is Q, radius is R. What will be the potential on the surface of sphere? Yes, what will be V? Anyone? Charge is capital Q, R is the radius. Nobody remembers the formula. We have done. Potential is what? What's the general formula for potential? How do we calculate it? Yes, Akifa?
KQ by R.
KQ by R. This will be K capital Q divided by R. This is the potential. So let me write it, the value of K. K is 1 over 4 pi epsilon naught R. Now, capacitance is what? Capacitance is the ratio of charge and potential. So if I put the value of potential from here, V surface that I have calculated, it will be Q divided by this whole term. This becomes what? Q goes in the denominator, 4 pi epsilon naught R in the numerator. So Q gets cancelled. Capacitance is what? 4 pi epsilon naught R. This is the capacitance for... Yes?
I did not understand.
Okay. See, Fatma, what is the potential? Is this clear? Potential on the surface, KQ by R.
Yeah.
KQ by R. Now, how can I write K? K is written as 1 over 4 pi epsilon naught.
Yes.
Yes? So
Yeah.
now see, if I put the whole formula in this, C is equal to Q by, this whole formula means Q by 4 pi epsilon naught R. So this term will go in the numerator? Yes or no? How do you divide it? If you have two quantities, you divide it in this way only, no?
Yes.
So charge will get cancelled, only 4 pi epsilon naught R will be left. So if you have a sphere which is conducting sphere, then you need not use this formula, C is equal to Q by capital V. You can directly use 4 pi epsilon naught R. For example, if I say the earth is a conducting sphere, then you know what are the values of all these. RE, if you know, if earth is taken as a conducting sphere. For example, we have taken, let's say earth is a conducting sphere. So what will happen? You just have to put in the formula of radius of earth. So C will be what? 4, pi is 3.14, epsilon naught is 8.85 into 10 to the power minus 12. R is the radius of earth, that is 6.4 into 10 to the power minus 6. So once you will solve this comes out to be 711 microfarad. 711 into 10 to the power minus 6 farad or 711 microfarad. So if you have conducting spheres, you can use this formula directly. C is equal to 4 pi epsilon naught R. If you remember when we did force, if the material got changed, then we used K epsilon naught. Dielectric got introduced. Whenever you remember, if we had force changing, then K epsilon naught used to come in the denominator along with whatever other terms, charges, and the separation between them. Similarly, here also, what do we have? The formula is 4 pi epsilon naught R. See, wherever absolute permittivity will be required, there will be requirement of the mentioning of the medium. This epsilon naught means what? Absolute permittivity of free space. This means this is clearly valid for free space. This is clearly valid for free space. Free space means what? Your air, vacuum. As soon as you change the material or the medium, what happens? Epsilon gets changed. As I've told you, we do not use epsilon. We use what? We use we use epsilon for that particular material. We stop using epsilon naught. Epsilon naught is unique in its value, having the value 8.85 into 10 to the power minus 12. If you change the material, then 8.85 into 10 to the power minus 12 is not valid because the material has changed. Now, whatever is the epsilon for that particular material, you just put in the values. But we already have a relation. K epsilon naught is epsilon. So if we use this, then capacitance becomes 4 pi K epsilon naught R. K will be given to you. K is the dielectric constant. This K is the dielectric constant. We'll see in questions how dielectric constants are provided. So if you get your dielectric constant as 3, so what you can do, instead of putting it every time, if you know what is the capacitance in air, see 4 pi epsilon naught R, this was the capacitance in air. So your C prime means C in any other medium. This becomes K times whatever capacitance is there in the air. So if the medium gets changed, let's say dielectric constant is 3 and the capacitance was what? Capacitance was, let's say 4. So now your new capacitance, this becomes 12. Directly just multiply whatever is the capacitance in air and you have the dielectric constant multiplied. So this formula is valid when you have the medium gets changed. Any other medium is kept. Whatever dielectric constant is there for the respective medium, put in the values. Otherwise, you have to utilize 4 pi epsilon naught R if it's a sphere. And if it's not a sphere, then simply use Q by V, charge per unit voltage. Clear? So quickly write this as well. Yes, Zaid, where were you?
Ma'am, I didn't get the time yesterday to join.
Okay. So,
Yes.
Zaid, just tell me one thing. What is the current chapter going in your school in physics?
Current chapter is like potential, electrostatic potential and capacitance. Same.
This chapter is going. And the topic?
And the topic is point charge that we are lagging behind. So, yeah.
Okay. All those who are preparing for their entrances like NEET and JEE. So in Learnivio, we are also offering additional classes. So if any one of you is interested, you can join that as well. In that, what will happen? See, I am covering CBSE plus NEET plus JEE level. But due to deficiency of time, due to lack of time, we are not able to do as many numericals as it is required for your entrances. See, board examination, this is perfect for your board examination. The questions that are coming from your previous years, all these are being covered and all the derivations. Even we cover some extra derivations. But for entrances, like especially JEE, NEET, extra effort is required, extra hard work is required. You need practice more, you need to speed up your calculations. So what we are offering is that you already have 2 days classes with us for all the subjects. If you have joined other subjects for chemistry, biology, mathematics also, you will have 1 day additional. These 2 days with me will remain the same, what we will be studying. In that 1 day, you will be getting taught by special groups of IITians and specialized teachers who have their expertise in the respective subject. And in that, what will happen? Suppose we have covered till capacitance. They will be covering till capacitance only. Let's say they will be covering chapter 1. We have completed chapter 1. They will also be covering chapter 1. Then they will what do? They won't be teaching you any theory. They will just be brushing up your basics and focusing on the questions that come in your entrances. So if you all are or anyone is preparing for entrances for medical or engineering, JEE or NEET, so you can join that additional class. In that, your question practices will boost up. Your speed will also be fast, and all the questions from previous year, new questions, that will cover. But it's just that you have to then devote 1 more day. It will be 2 days your regular classes, because this you cannot miss. This is your basics. In addition, all those who are preparing should join those classes so that they do not need to prepare extra, because after 12th you get hardly 1 month time for preparation, for especially for NEET.
Teacher, one doubt.
Yes, Atif, say.
Can we write C as R by K? Where K is 1 by 4 pi epsilon naught. So this will be the reciprocal, right?
What? Can you repeat? C as?
Can we write C as R by K if K is 1 by 4 pi
By
epsilon
K,
naught?
yes, R by K only. See, this is, if I do not expand it, K is equal to KQ by R. If I do not expand it, then what was left? This R by K was only left. No, charge got cancelled. So you can write in this manner, but ultimately what happens? You have to put this value as 1 by 9 into 10 to the power 9. Whatever is the value of this K, the value of this K is 9 into 10 to the power 9. No. So if you have the radius, you can divide it by 19 into 10 to the power 9. Rest of the thing will remain the same. If that's what I'm saying, Atif, if your medium is air, then only. Fine. If your medium gets changed, then put it K epsilon. Fine.
Yes, teacher.
Ma'am, can you please show the previous one? A second. Thank you.
This much?
A bit more.
This much also?
that's fine.
No.
Thank you, ma'am. I'm done.
And this part, what about the lower portion? This, you writing?
Yes, ma'am, I finished all this.
So then let's discuss what's the capacitance of parallel plate, capacitance of parallel or capacitance between parallel plates if completely filled by dielectric slab or dielectric medium. So these are basically two plates. Two plates as in proper two rectangular plates like this in this manner. Two plates are kept, and if I join this by the terminals of battery, let's say in this manner, what will happen? The positive terminal, this is the positive, this is the negative terminal. This plate will develop positive charge and this plate will develop negative charge. So similarly, that's what I'm representing it through a line. This line means that parallel plate. This is the parallel plate that has been kept. So this is the positive plate, let's say. This is the negative plate. Now let's say separation between both the plates is small d. The separation between the plates is small d and A is the area of both the plates. Now regarding electric field due to the positive plate, it will be directed away from the plate. This is your positive plate, so if you direct yourself away from it, this will lead you in this direction. For the negative plate will attract it. Just wait for 2 minutes. All right. So I was discussing that this electric field direction for the first plate, this will be downwards, and electric field for the negative plate will be towards the plate in this manner. This is the direction of electric field. Let's say sigma is the surface charge density. Now, electric field, if you remember, if you have plates, we have done a case when we were discussing application of Gauss theorem. Electric field, net electric field will be E positive, means this electric field plus this electric field. Now, electric field, if your surface charge density, this is sigma, then your electric field for single plate becomes sigma divided by 2 epsilon naught. Recall, we have done this in Gauss theorem. So for E plus, this will be sigma by 2 epsilon naught. For E minus, it will be sigma by 2 epsilon naught. This is the net electric field. So if you add them, you get the electric field as sigma by epsilon naught. Now, if you remember electric field and a relationship, we have done it with potential. What was that relation? A relation between potential and electric field.
dV by dx.
dV by dx, correct, Krishna. dV by dx, or if I write it the magnitude, this will be V by D. So potential from here will be simply electric field multiplied by the distance. And this formula is also used. Please remember the steps in this derivation that we are doing, because we'll be taking different cases, and in that these steps will get repeated. So please remember the whole procedure for all the cases that we'll do. The same steps will be there. First, we'll be calculating the electric field. With the help of electric field, we'll be calculating potential and then the capacitance. These 3 steps will remain same. So you should learn the derivation in the class only. So V is equal to ED. Let's put the value of E. E is sigma by epsilon naught. So potential becomes sigma D by epsilon naught. Surface charge density. Surface charge density means charge per unit area. This is surface charge density. So let me put this as well. V will become Q small d divided by epsilon naught A. Now capacitance. Potential, if I have, I know the charge Q, I can get the capacitance easily. Capacitance will be Q by V. So see, this is the charge multiplied, the potential is in the denominator. So this will be epsilon naught A by QD. So Q gets cancelled. Capacitance is what? Epsilon naught A by D. This is the capacitance for 2 parallel plates here. If the material gets changed, this is valid for a material that is having normal 2 plates are there. Now the dielectric must be having some value as well. So as I've told you, dielectric constant has its value K that we write. So just add K along with this. Wherever you are writing epsilon naught, this will have additional K. This K is the dielectric constant that will be given to you. Dielectric constant. So this is how you calculate the capacitance between 2 parallel plates. Now you can get different cases. Here what did we take? The whole parallel plate, this had been filled with a dielectric medium. Completely filled dielectric medium. So directly use the formula K epsilon naught A by D. Fine, just note down this, then we'll see one more case of it. So you should remember the step: calculation of electric field, potential, then capacitance. So if you have two parallel plates without dielectric, then simply use this epsilon naught A by D. This is the capacitance without the dielectric constant. And if the dielectric constant is there, completely filling the medium, then use K times epsilon naught A by D. So from here also you can see the new C that you have means the new capacitance of the medium. This will be K times the capacitance which is there in the air. Till here, any doubts? Is this clear to all of you?
Yes, ma'am.
Yes.
All right. See, if what happens if we put the dielectric slab which is not completely filling it, if we take parallel plate capacitor with dielectric slab partially filled. Now the dielectric slab is not completely surrounding your material. These are the two plates of the capacitor. This will be positively charged. This is negatively charged. Sigma is the surface charge density. Separation between the plates is small d. Area of the plates is capital A. Now, if I insert a dielectric slab, means this slab I have inserted. This is a dielectric slab. Dielectric word I am repeating. This is all the definition of insulator is valid for dielectric. And let's say the thickness of this is T. So T is the thickness of the slab. Now there will be electric field of the dielectric and there will be electric field of the air. This is air. The rest of the medium is air because dielectric is not now completely filling. So see, there will be two electric field because there are two different materials now. One is the air, the other one is the dielectric. So if I talk about the electric field ED of the dielectric, this will be sigma divided by K epsilon naught. Let's say dielectric constant is K. So this will be what? Instead of writing sigma by epsilon naught, we will be writing sigma K by epsilon naught. But regarding electric field in air, we will be writing what? Sigma by epsilon naught. No K is necessary. Is this clear? Why are we writing this? See, electric field due to the dielectric. This will be sigma by K epsilon naught. K will come because this is the material now. Material has been changed. The material is now dielectric. Now, if I write the electric field for air, it will simply be sigma by epsilon naught the way we have done over here. How it came out to be sigma by epsilon naught. Similarly, here it will also be sigma by epsilon naught. Now, the important part, potential is again ED, means electric field multiplied by the distance. Now see, you don't have a single electric field, you don't have a single thickness or distance, so each will get multiplied. Electric field for air, E naught. Fatima, can you tell me what is the thickness that I'll take?
T. No, for air, no. D minus T.
Perfect. It will be D minus T. See, rest of you also. Air is where? Air is apart from the dielectric medium present. That dielectric slab of thickness T, this is also covering some area. No, this is also having its thickness. If the separation between the plates is D and I remove small t, what is left? D minus T. So D minus T, this will be left. Now, electric field Yes, Kulsum, now you tell me, what will be the distance that I will take or the D value for dielectric? Yes, Kulsum, try. D minus T was for air. For dielectric, what is the thickness? Kulsum? Yes, Fatima. Okay, Kulsum, tell me, what is the thickness of the dielectric? Dielectric slab thickness. Look at the figure that is given. Electric field for air is in this part. So we had considered this excluding this. Now we are just considering this.
T.
T. It will be T because the thickness of the slab is T. Now this was the main part that was required. Rest now all the steps are repeated. You will be putting the value of electric field. Let's put the value and check. It will be, it was air, no? So this will be sigma by epsilon naught D minus T. For dielectric, it will be sigma by K epsilon naught T. Put the value of charge. This will be Q by A by sigma is Q by A. So I'm just putting the value of sigma. Epsilon naught D minus T plus Q by K A epsilon naught T. Let me take Q A epsilon naught. This can be taken common. So if I take Q by A epsilon naught as common, D minus T plus T by K from here, this will be left. I've just taken this common. Now, capacitance will be what? Ratio of charge by potential. Charge is Q divided by this whole term, Q by A epsilon naught, this whole term, A epsilon naught. And Q is multiplied Q divided by A epsilon naught D minus T plus T by K. So this is in the denominator, this will go in the numerator. And charge will get cancelled. So this will be epsilon naught A by D minus T plus T by K. See, if you put the dielectric slab's value as 0, means the thickness as 0, what will you get? This will be 0, this will be 0. It will be epsilon naught A by D. When the thickness of dielectric slab is 0, what is meant by that? That means there is no dielectric slab. So this was the formula, no, that we were getting epsilon naught A by D. So you can check the value of capacitance from your this formula also. So just note down, this is capacitance for if a dielectric slab has been introduced and the thickness is T. Then we'll do one last case. If you have any doubts, just ask me. You can write me as well.
Ma'am, in the previous case, there was no dielectric slab, right?
Dielectric slab, see, first we started with this. There wasn't any dielectric slab whose formula came out to be C is equal to epsilon naught A by D. Then this which I have written, this part, this is when both the plates have the dielectric slab, but it is completely filled. For that you use this. Now if it is partially filled, then we use this case.
Okay, ma'am.
Now the last case. If instead of the dielectric slab, if I place a conductor, now see, there will be a very minute change. Can anybody tell me what is the electric field inside a conductor? Yes, anyone? We have done it when we were discussing electric field, properties of electric field lines.
Zero.
Yes,
ma'am.
Krishna, 0. Perfect. See, electric field inside a conductor, this is 0. Remember, we have done electric field lines are always perpendicular on the surface of conductor. They do not penetrate through it. If they do not penetrate through it, the electric field lines will be 0. Also, we have done the case of a sphere. In sphere, we had seen 3 cases: electric field outside, electric field at the surface, and electric field inside. Then there was some value for electric field both outside and at the surface. There was no value of electric field inside. So electric field inside the conductor is 0. This is just the difference that will come. See, this is air, this material is air, this is E naught. D is the separation, and again T is the thickness of this. Now see, E naught will be sigma by epsilon naught. EC here this time will be 0. Now, when I am writing the potential, V is equal to ED. Remember, see, as I have told you, the steps will be the same. V is equal to ED. Now, potential electric field for this air, this is E naught D minus T. But here we have EC, this is 0. So V is what? Sigma by epsilon naught D minus T only. Till here we have only the part. So this is easier than the previous case. Now what will happen? Put the value of sigma as Q by A. V will be Q by A epsilon naught D minus T. Now, the ratio capacitance is what? Charge per unit voltage. Charge is Q divided by the voltage. Voltage here is Q D minus T. And A epsilon naught will be here. Q gets cancelled. C is what? A epsilon naught D minus T. This is the formula. Just I'm summarizing it, what we have studied till now. First case was that if 2 parallel plates are there, the medium completely is air, then you use this formula, epsilon naught A by D. If your parallel plates are there, whole medium has dielectric constant K, then this will become K times epsilon naught A by D. If your third case, if only a portion of or a part of this dielectric slab has been kept, then use this formula. Not then use this epsilon naught A D minus T plus T by K. And the last case, if instead of the dielectric slab, you have a conducting slab here with the thickness T. Then C will be epsilon naught A by D minus T. So these are the 4 cases that we have studied right now. For airs, epsilon naught A by D, dielectric, just add K. Dielectric slab is not completely filling it. So use this formula epsilon naught A D minus T plus T by K. And instead of dielectric slab, if you have a conductor, use epsilon naught A D minus T. With the help of these 4 formula, all your questions of parallel plate capacitors will be covered. Fine. Is this clear to all of you?
Yes,
Yes,
ma'am.
ma'am.
Okay, tell me one more thing. Are you all able to open the Learnivio portal app that you have, or is anyone facing difficulty in logging in?
No, ma'am. We can open it.
You can open it, no? So please start submitting your assignments. Now I'll be discussing the assignments in the next class. Only few students were submitting. Atif, Krishna, Fatima has also submitted. Zaid has also submitted. Few students have submitted. But now please be regular and start submitting your assignment, whatever you get after the class. Hardly 4 to 5 questions are there. And those are also based on what we have studied in the class. So if you have any doubts regarding the assignment, that will also be covered. Hanifa, are you not receiving the assignments on WhatsApp as well?
No, I received them, but I don't know where to submit it.
Sorry, could you repeat?
I received them, but I don't know where to submit it.
Okay, just submit on the WhatsApp only. Wherever, at which number you are receiving them, just submit there. Then I'll receive it. Don't worry.
Oh, okay.
I think by now all of you must have written this. No? Let's do the what is the energy stored in a capacitor. So this is also an easy topic. Now, regarding the energy stored in a capacitor, if I say these are two parallel plates, the complete charge on them, this is capital Q, the whole charge on this. And the whole potential for it is V. Both the plates are there, positive, negative. connected to the circuit. Fine, this is the setup that we have. Now, in order to calculate the work done, if I take up a very small charge, let's say dq, this is a very small charge that I have taken in order to find out what is the total charge. So in integration, what we do, as we have discussed before the beginning of this chapter only, integration and differentiation will be constantly used. In integration, what we do, if we know a smaller part, we can expand it. Integration is like you are adding dq plus dq plus dq plus dq and so many infinite dq together, because dq, this d term, when we use this, is infinitesimal small term, a very 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 small term is used. So now if I know whatever is the work done for dq, I can expand it from zero value, means minimum charge, to the maximum value, that is q, and I can get the work done. So work done in charging it, work done in charging this, let's say this is dq, and the potential right now, potential for this is V. This was the formula of potential or the definition of potential. No, potential was what? Potential was work done in carrying a unit positive test charge. If you cross multiply, work done will be charge multiplied by the potential. So this is the definition of work done. Now I just have to integrate it to understand what it is. But see, dq and v cannot be integrated together. Obviously, I want to have v in terms of charge only. So I'll write it work done. Let's say this is dw. This will be dq. V is what? Capacitance is charged by V. So V will be charged by capacitance. Now this has to be integrated from 0 to capital. This you should understand till here how to write this. This is your physics. Rest of them is mathematics, basic calculus to solve this. So you should understand why we have written it. Why from 0 to Q? Because capital Q, we have assumed that this is the charge on it. Now integration, dw, this will be the whole work done. Q dq. If you have a term, let's say Q to the power n, add 1 to the power. So Q, you have the power as what? 1. Add 1 to it. And whatever is this, divided by n plus 1. This is what we have studied in integration. Q to the x to the power n. So right now, instead of x, we are having Q. So this will be Q to the power n. N here is 1. Add 1 to it. 1 plus 1. Whatever is the exponential power coming, just divide it. 1 plus 1. And right, rest of the term, rest of it is C. Integrating, you are integrating it from where? From 0 to capital Q. So this becomes what? This becomes 1 by 2C. 1 plus 1 is 2. Q square, integrating it from 0 to capital Q. Now, once you have this, you have to write the upper limit. So 1 by 2C is constant, you won't change it. Upper limit, capital Q, whatever is the power of your integral function. What is the power? 2 is the power, so this will be Q square, plus lower limit, this is 0, power will be 2. So this will be what? This will be 0 square. So 0 square, this is 0 only. So work done will be what? Work done, this work done will be Q square divided by 2C. Now, whole of the work done gets converted into which form? Potential energy. This work done gets converted into potential energy. So you have the formula, first formula of potential energy stored in a capacitor. Energy of a capacitor as Q square by 2C. So if you are given charge and capacitor, you can use this formula. This is the first one. But what if you are given capacitance with voltage? No charge is given. So simply replace Q as CV. If you write Q as CV, this will be C square V square divided by 2C. Q square will be what? C square V square. 1C will cancel. This will be half CV square. This is the second formula of energy. When to use this? When you are given capacitance and voltage. What if I'm given only voltage and charge? Then I have to replace capacitance. Capacitance is what? Q by V. Put Q by V over here. Half Q by V. Instead of C, I'm writing Q by P. V squared. So V gets cancelled. Q is equal to Q, not Q. Sorry. U will be QV divided by 2. This is easy. The derivation is also easy and the questions also come directly. Mainly you have to remember its derivation, which is small, but this derivation does come in your examination. So you have to understand this derivation because this has appeared in your past year questions. All right, this is your energy stored in a capacitor. So quickly write it down, then we'll do a numerical combining all of them, what we have studied till now. All right, so the question says that a parallel plate capacitor with area of the plate as 10 centimeter square is connected. The separation between both the plates, it is 5 millimeter. A dielectric slab has been inserted. The thickness of the dielectric slab is 3 millimeters and the dielectric constant is 2. So Fatima, Munir, you tell me, out of all the 4 formula that I have written, which one should be used in this case for the calculation of capacitance in the first part? Fatima, Munir. Yes, Fatima, are you able to hear? Hamza? Hamza, out of all these 4 formula, which one should be used in this case? 4 we have done, no, for the calculation of capacitance. Which one should be used in this case? Hiba? Yes, Kulsum, please tell us.
Is it 2, ma'am?
Fatima is correct. It will be the third one. See, Kulsum, reason, see. The separation between the plates. The separation between the plates is what? The separation between the plates is 5 millimeters. Now the dielectric has been inserted whose thickness is what? Whose thickness? This is 3 millimeters. Now this is which case? You use the second case when the whole material covers. If your 5 millimeter was overlapping with this 3 millimeter, then we would be using the second case. Now what is happening? Now the dielectric slab is not completely filling it. So we have to use that case when the dielectric slab partially covers your medium. Is it clear to all of you why are we using the third formula for this case?
Yes, ma'am.
Yes.
Oh. So we'll be using this one. So you have to identify which one to use. Instead of the dielectric slab, had it been a conductor, we would have been used the fourth part. Had this not been 3 millimeter, had it been 5 millimeter, then we would have used the second part. If it hadn't been any material, air, simply air, we would have used the first part. So the answer for capacitance is epsilon naught A d minus t plus t by k. Now all the terms that you have, 10 centimeter square is the area. This becomes 10 into 10 to the power minus 4 meter square because you have to have all the SI unit, everything in SI units. This is area as 10 to the power minus 3 meter square. The separation between the plates is 5 millimeter. Convert it by multiplying 10 to the power minus 3 meters. Similarly, thickness is 3 millimeters. This will be 3 into 10 to the power minus 3 meters. Now just put all the formula that you values you have. K is what? K is only missing. This is 2. You know epsilon naught. You know now A. If you put it, this will be 8.85 into 10 to the power minus 12 for epsilon naught. Area you have as 10 to the power minus 3. This gets divided by D, 5 millimeters minus the thickness 3 millimeters plus the thickness 3 millimeters by the dielectric constant. Whatever you get, you can take 10 to the power minus 3 common. So this 10 to the power minus 3 will get cancelled by this. And just try to solve this. This will be 1.5, 2 minus 1.5. Okay, so this much Faraday will be your answer. This will be the capacity. Just solve it after the class, see what is coming. Then the second part says charge if it is connected to 100 volt. Your V is 100 volt now. V is given to you 100 volt. This is coming, Atif, 3.54 into 10 to the power minus 12.
Yes, teacher.
All right, I'll check and let you know whether it's correct or not. I think it should be 10 to the power minus 12 is right. This I remember. 3.54, I'll check and let you know. Others also please check. If the same answer is coming, then this will be the answer only. 10 to the power minus 12 will be there because minus 3 gets cancelled. You just have to solve them. V is 100 volt. See, V is 100 volt. Q is equal to what? CV. You have C from the first part. Multiply it with 100, you get the charge. If you are asked, so I think this will be somewhat 8.85 into 10 to the power minus 12 divided by 3.5. So let's use this till the time. This will be, or the answer that you have shared, Atif. We can use that by 3.5 multiplied by 100 means C from the first part multiplied by the voltage. This is Q charge. And energy, it is also asking you the energy stored if it is connected to 100 volt. Then energy is what? You can use any formula now. You know the value of voltage, you know the value of charge, you know the value of capacitance. So you can use any relation. If we use half CV square, then C is this 8.85 into 10 to the power minus 12 by 3.5. V square will be 10 to the power 4 by 2. This much joules. You can use half Q square by C. You can use QV divided by 2. This one also. So quickly note down the solution of this. And please just calculate capacitance and let me know what is your answer coming. Yes, it will be 2.5 something. So 2.53 into 10 to the power minus 12 and 2.52 into 10 to the power minus 12. Okay, Krishnatif, yes, you both are right. This will be the answer. Rest of you also please match if this is coming. 2.52 into 10 to the power minus 12 farad. principle of capacitor is a very, very small topic. The principle on which the capacitor works. See, to understand this, you can use this relation that we have seen. C is inversely proportional to V. Why? Because C is equal to Q by V. So C is inversely proportional to V. If I keep on reducing potential, I keep on reducing this value, what will happen? C will ultimately get increased. This very small concept is just on which the capacitors work. See, if I take this plate, let's say I've taken a plate, I've kept it on insulating stand. This is some insulating stand. Let's say this is positively charged and it has some potential. The other plate, this is negatively charged. But because of induction, it can happen that it can be having minus negative, positive charge as well. But see, this is the case. And let's say we have also put this on insulating stand. Now, if I perform the process of earthing, the potential of this will become what? Zero. See, whenever earthing is done, potential becomes zero. If you have forgotten what was earthing, earthing is the transfer of electrons from the body to the earth or from the earth to the body. Now, whether it is from the body to earth or earth to body, that does depend on directly whatever is the charge the body is carrying. If the body is carrying positive charge, then electrons flow from the earth to the person, not person or whatever is the body. If the body is negatively charged, then electrons flow from the body to the earth. This we have discussed in the first class only. So that was the process of earthing. In earthing, potential becomes zero. You have to remember this. Now see, if potential of one plate becomes zero, automatically the potential of this will be more now. The potential difference will increase. The potential difference will decrease because this was zero. Now what will happen? As I have decreased one potential, the capacitance increases. So this is a very small topic, very basic principle on which the capacitors work. So capacitance of a conductor. If you have a conductor, then the capacitance of the conductor, it can be increased by keeping an uncharged earthed conductor near it. This is the principle on which capacitors work. So kindly note this down as well. Principle of capacitors. You do get this question. What is the principle of capacitor? On which principle is the capacitor based? Working of capacitors. So you have to mention this point. Okay, the last topic for today is, see, parallel plate capacitors we have done, the formula of the parallel plate capacitors, all the four cases we get in parallel plate capacitors, what is the energy stored and what is the principle of capacitors. Remember, I have told you there are three kinds of capacitors. Parallel plate capacitor is there, spherical plate capacitors is there, cylindrical capacitors is there. So cylindrical capacitors mainly comes in your entrances. In NEET it has also come, and in J it has already come many times. So cylindrical capacitor is important for your entrances, but you should know the derivation for spherical capacitors. Spherical capacitors. So we'll just do the derivation. What is the formula for it? So for this, I'm taking one sphere. Let's say the radius of this smaller sphere is R1 and the radius of this sphere is R2. We have to find out the potential difference between the spheres, and then we'll put it in the formula of capacitance. We'll get the capacitance. So in this way, you have to remember all the derivations, because see, at the end, what will happen? There will be so many derivations that you will be forgetting what is the first line. In the exam, mainly what happens? If you are able to recall the first line, then you are able to do the derivation. So it's better you should remember how it has started, because once you are beginning it or once you have commenced it, then you will be able to solve it automatically your own. So this will be, let's say this is R1, this is R2, this is Q charge for it. So by the process of induction, if you remember in the beginning classes, we have studied process methods of charging by friction, charging by conduction, charging by induction. So in case of induction, what will happen? Due to induction, if this is positively charged, automatically the other charge will be negative. This is what we have seen, no? Temporary electrification. Just revise if anybody has forgotten what was that. So this will be minus Q for this sphere. This is minus Q and this is plus Q. So we have to find the potential difference between the spheres. V will be okay, Fatima, you tell us what will be the potential due to this sphere, inner sphere. What is the radius, Fatima, of the inner sphere?
R1.
Charge.
Q.
Now
KQ by R.
this will be
KQ by R1.
KQ by R1. Hanifa, you please tell us what will be the potential for the bigger sphere?
We take you by R2.
R2. Just remember, potential is a scalar quantity. So we have to consider the magnitude as well as the sign of the charge. So this time it won't be plus KQ by R2. This time it will be minus KQ by R. Fine. So now this is the potential. You have to put it in the capacitance. This is very easy. The derivation of spherical capacitors is easier than what you have studied for parallel plate capacitors. KQ take out common. 1 by R1 minus 1 by R2 is left. Just take the LCM only, because you will get a simplified version. This is Q by 4 pi epsilon naught. This will be what? R2 minus R1 by R1 R2. Just I have taken the LCM. So I have the potential. Now I have to get the capacitance. Capacitance is charge divided by the potential. This is charge divided by Q, R2 minus R1. And these portion, this will go in the numerator. R1, R2. QQ gets cancelled. Capacitance for spherical plate capacitors, this is 4 pi epsilon naught R1 R2 divided by R2 minus R1. This, or you can simply write R1 R2 by R2 minus R1 K, the constant that you use. This is utilized a lot. Sometimes in your entrances as well, this is directly given. The capacitance for spherical capacitors is this. So you just have to identify this. So please note this as well. Done?
Yes, ma'am.
Yes, teacher.